option is what you need to understand very clearly, the instance type. So this is based on your application requirement. You go and choose the AWS EC2. Sorry, AWS EC2 provides a wide range of selection option, and each instance type is optimized for specific use cases. Okay, let me show you these options first. So you have multiple different sizing option. See, there are certain characters it is starting with, right? You can see it has got T, it has got C, it has got A, and different naming convention, right? I'll show you. I mean, you have got multiple tabs here. So where we have a wide range of option. So they are giving you varying combinations with different CPU, memory, storage, and technologies. Okay, so I'll tell you how to choose a particular instance type now. So Amazon is providing you different instance family, instance type, and each business application or utility application, some of them might need more CPU, some of them might need more network, more disk storage, some of them might need more memory. So different application will demand different hardware configuration and hardware requirement, right? So now AWS has got this naming convention with grouping, or it's like instance grouping or instance family. So if you look at something like D, it is mainly referring to disk, or you can also talk as dense storage or a disk. If you see something starting with R, it is referring to your RAM, which is nothing but your memory, random access memory. And if something is starting with C, it is referring to CPU, compute. Okay, if some instances are starting with M, again it is memory. Okay, some instances will start with memory optimized also. And if you have something like starting with F or G, let's say G first. This is like for graphics processing unit. And there is some category called F, which is called, I mean, not family. It is for FPGA. FPGA stands for Field Programmable Gate Array. See, these type of instances might not be available in all your data centers or all your region. Field Programmable Gate Array, it is like specialized hardware, right? It is used for hardware acceleration for your application codes, or for enhanced security. You have this FPGA option. It is not available in all the data centers. You have to go and check whether these options are available in that data center before you create it. So your instance family has got meaning. So whatever letters that they are using to start with, that has got a meaning to each of those things. And you always have to go with the latest generations or the latest versions. So after this number, you could see 1, 2, 3, and so on, right? And let me just try to filter. For example, if I just say the ones which are available with FPGAs, or the ones which are having let's say instance type, I want to say instance type equals. So they are giving you a lot of options here, right? And if you look at here, it is having T1, T2, C1, C2, C5, and there are a lot of numbering after that. So this numbering, it refers to the version or the generations that we have. So always go for the latest generation. If you have something like example T1, T2, T3, and so on, these are all different generations and technologies. Always choose latest version or generation. It gives better performance, and even the pricing will be cheaper. Okay, and the older versions are mainly for legacy support. Older versions, if your operating system or application is demanding legacy support, it is older versions are for legacy OS or app version compatibility. Okay, so always go with the latest one if there is no compatibility issues with your application or business application. So, and then you will also see some denoters. For example, if you are seeing something like, let's say R5A, so this A might be denoting AMD processors and so on. So it might have some technology linked to it. So always have a, see, AMD processors might be cheaper compared to your Intel processor. If you want to balance your price as an architect, you can also go with AMD processor option in your instance family. Now coming to the core area, so you have different optimized instances for different workload requirement. It might be for CPU or memory or network or storage. You might need various combination for your system. So generally, if you don't know your application is needing higher CPU or higher memory or higher disk, you can generally start with the general purpose. So general purpose is for general workloads without any special requirement, without any special requirements identified to start with. Okay, definitely some workloads will have some specialization, but initially, like you will start with general purpose, you can think that as a baseline to start with, or it is the stuff which has got the balanced amount of CPU, memory, networking, and storage. Okay, it will all have all these capabilities in a balanced level. There won't be higher ratio of memory, there won't be higher ratio of CPU here. So generally, the general purpose workload, we use it for workloads like small web servers, small database servers, or small app servers. Generally, we use it for testing purposes, development purposes, and mostly for line of business application, so for initial basic application needs. So it can be considered as burst line, or it can be considered burstable means you can increase the size or change the size at a later time. So in this particular case, maximum network you will get a bandwidth of 5 Gbps, and you will have limitation in terms of number of network adapters. So general purpose is for less critical workloads. Okay, don't use it for high critical workloads. Don't do trial and error. The reason I tell that, see, for production workload, you might have already done the UAT testing, user acceptance testing, system integration testing, or system acceptance testing. So you might have already done all the benchmark testing before you go into the production. So when you are reaching the production stage, you will already have some baseline about your, or you will have some understanding about your application, what exactly it is looking for, whether it is demanding more CPU or whether it is demanding more memory. You will get to understand that. But some application, you will automatically know based on your prior experience what it will look for. For example, if you are talking about network appliances, or if you're talking about some web servers, or I'm talking about some mid-size usage or moderate usage. Okay, so very less usage, you can go for general purpose. For moderate usage, or for medium size database servers, or medium size application server. See, for these cases, for network appliances, it will do a lot of routing, switching, it will do a lot of network traffic handling. So obviously the web servers will also have number of concurrent connection, number of users will be high. So what we generally do is, when there is a very high network usage, when there is a very high network traffic, automatically your CPU usage will be high. So on all your machines where you are having applications which have a lot of concurrent connections, concurrent sessions, then it will consume more CPU cycles. When the network usage is high, your CPU cycles will also be high. So when you have systems which needs very high network consumption or network traffic will increase CPU cycles or CPU usage. So in that case, like for example, if you're doing some batch processing, or if you're doing some multiple parallel processing on your applications, so for such cases, what you can do is you can go for compute optimized workload. So compute is mainly referring to your CPU high usage requirement. So general purpose is for your less critical workloads and general workloads, but then the compute optimized is used for the applications which are needing very high CPU usage, and in turn even the network usage will also demand more CPU. So in order to balance the usage or balance the pricing, what Amazon generally does is they use different processors or processor family to give better pricing or competitive pricing. See, in the first one, in the general purpose, generally Amazon uses Intel Broadwell processors, or they generally use Intel AVX version 1 or version 2 processors, where it is kind of comparatively cheaper when you go for your Intel Skylake processors, or these are all very, very powerful processors. That's the reason like we are using Skylake for CPU cycle, whereas the memory technology that they use for this particular hardware might be of comparatively lower cost. See, when I go for the next category, memory optimized. Memory is heavily demanded by your relational database servers like your Microsoft SQL or Oracle databases, or for your database systems, or for your database servers, relational DB servers, there will be a very high memory demand. So anything that is processing very heavy data sets, it will need a system which is like a databases or data warehouse or in-memory analytic systems or in-memory caching systems. This needs a lot of memory to be memory for the application, and even for your SAP application also, you can go for memory optimized, because that is a heavy data set processing system, right? So wherever you are processing heavy data sets or your application is processing a lot of data, like SAP HANA database or SAP NetWeaver or an SAP Hackathon system, so Hackathon will need more memory. So in this particular category, what Amazon will do is they will go and use processors like AMD processors to balance the pricing for the customer, because in memory optimized you might be using a very high end DDR RAM or the latest version of DDR RAM or high technology memory unit, whereas here the focus is on the CPU units, here the focus is on the memory unit. So they will use specialized memory units on the memory optimized. And the next thing that you need to understand is, in memory optimized, you will get lot of memory per CPU. So if I go and check it here, see if I go and filter out by memory optimized, let's say. So these are all, yeah, memory optimized. See, if you look at here, for each of your memory, for 160 memory GB, okay, you have 40 CPU. Okay, for 64 GB, you have 16 CPU, virtual CPU. So here you can see what I'm referring to. For each of your memory, you will have more ratio for your CPU. So for 160, you have just like good amount of ratio. But if you are going for compute optimized, let's say compute optimized here, right? See, you can see 1:2 ratio mostly. So for 2 CPU, you get only 4 GB RAM. For 4 CPU, you get only 8 GB RAM. So the ratio of compute or CPU will be higher in compute optimized. So anything that starts with C, it's for compute optimized, right? So it will follow a kind of 1:2 ratio in most of the cases. So in compute optimized, it will be more or less 1:2 ratio for your CPU to memory ratio. Okay, so you will have more CPU per memory in compute optimized, but then in memory optimized you will have more memory per CPU, because our requirement for your application is about more memory, right? You can see 1:4 ratio, or you got a lot of memory in this one, in the series starting with M. You can see you can have 16 GB memory for 4 CPU, and if I scroll down you can see more numbers also. For just 48 you are seeing 192 GB of memory. Okay, it will not follow the same 1:2 ratio, instead it will have 1:4 1:5 ratio also sometimes. So you will get more memory processing power here in memory optimized, you will get more CPU cycle when you go for compute optimized. So there is another category where you might have more acceleration on the computing. For example, when you go for the graphics optimized, you need the graphics GPU card. Okay, so generally, you know, right, when you want to do some gaming laptops or desktop, you go and purchase the NVIDIA card or a specialized graphics card. And even in the public cloud also, some of the applications like the gaming apps or your video streaming apps or some live streaming application which need some of the business application might have graphics rendering, video processing, and all those requirement. Even some line of business application will also use that. So if there is a graphics requirement, you can go and use the graphics optimized hardware, where you will have a specialized GPU card in that particular system. Now, if you want to go with storage optimized, if you are using some big data systems, or if you are having systems where you need a lot of storage processing or disk requirement, you can go for disk or storage requirement. So in generally, like when you go for disk, what will be your requirement? You will be expecting from your application to that disk, you might be expecting more IOPS, okay, or you might be expecting very high throughput, or you will expect very high reads and writes, right? This is input output, or writes and reads and writes are almost similar. So you will expect very low latency to your disk. That is what you will expect. So in order to provide that, generally Amazon uses SSD technology, especially NVMe SSD technology, solid state disks or drives, to give you better disk read write or IOPS for your from your system. And also at the network level, it also uses InfiniBand technology, which provides you 40 Gbps transaction. Even if you are having a network attached storage or having some disks on the network, it will also be useful. So the use cases will be if you are using some data warehousing system, or if you're using NoSQL, not only SQL DBs, or let's say you have some OLTP or distributed file system applications. So for such cases, you can go for storage optimized. Big data, Cassandra DB, MongoDB, even for Redis caching also, you can use this storage optimized. The final one we have in this list is accelerated computing or confidential computing. So this is mainly for systems which are very high critical and which are demanding very high processing or stuff. See, we have a category called accelerated computing category. So this is for high graphics rendering, or not rendering, app streaming, video streaming, or for your on-premises supercomputers or grid computers, it might need a lot of processing. See, if you have Apache Spark on your on-premises, or if you have multi-processing MPI applications, or if you have some applications which are discussing about weather pattern or chemical labs. So these are all systems which are kind of very high processing requirement. Like it's generally catered using your supercomputers or grid computers in your on premises. So if you are running those application on grid computing or supercomputers in your on premises, you can bring those applications to accelerated computing, where you can get a lot of hardware acceleration. They will use a lot of technologies to provide accelerated computing. In this particular type of hardware, they will enable turbo boosting on your processor. They will enable hyper threading. They will use a lot of technologies to boost your processing, to enhance the number of CPU threads cycle on those systems. Okay, now you have these many categories. So based on your business application requirement, you can go and choose which one might be ideal for your business requirement. So if the customer is asking a server for database, obviously you can recommend memory optimized. If it is for network appliance or business application, you can generally start with compute optimized. If your application needs high graphics or graphics requirement, go for graphics optimized. If there is a lot of network throughput or disk throughput IO, then go for storage optimized instance type. So any questions you have on this? No questions?
Mr. Vinesh here.
Yeah, yes, Vinesh.
So, yeah, hi, how about the storage optimized and accelerated computing? I mean, those families, like on which, for example, if we have D, it stands for disk storage, and we have the storage optimized stands for D, or what? How we categorize the alphabets on this?
Yeah. So for D, it is storage optimized. It starts with D, and sometimes it might
Okay.
have some specific numbering. So yes, for storage optimized, it is generally D. Yeah, that is true. So for dense
Okay,
storage,
accelerated computing.
for accelerated computing, I think it starts with P or G, I think. Let me double check. I think it's P. Yeah, I think if I remember it, it's like having more performance, right? So accelerated computing, more performance means it's P series.
Okay, any idea about the Z one, all the Z types?
Is that type, huh?
Yeah.
Okay, let me check. See, there are certain subcategories. Maybe it is for. I've seen there is one more category called HPC series, which is again high performance computing series. But let me check. HPC series is for high performance computing. Okay, so did you check in the internet what exactly? Maybe some advanced technology within your memory or compute. Is that? Let me check. So did you find a specific drive letter? Okay, is what you said, right? Any specific full stuff you have?
No, I just
Mhm.
came across, while scrolling
Let me
your
check.
screen. I mean, you showed me right
Oh,
here.
is it? Okay, okay. Is it? Okay, so this is like, is that 1D, right? Mostly, I think it looks like SSD type. Looking at the ratio, it is memory optimized. Okay, so it's not a separate option. It should be memory optimized only. So memory optimized generally it starts with R for memory, or sometimes it might start with X, M, or sometimes I have seen X also. Sometimes I could see nowadays Z also has been used. So there will be some reason for that. Okay, maybe they are using some extension or some advanced capabilities within your memory technology, and that's the reason they are using terms like X, Z, and so on. So there will be some reason for that. There is some denotion on why they have used that character. But mostly it looks like it is under your memory optimized. But mostly it used to be R and M in the past, but I could see now some new numbers coming up.
Yeah. Stan, Anand
Yeah.
here. Can you
Yes.
go the screen, that screen, one back, that back screen?
Yeah.
Here you can select that instance type. That instance, if you are sure, right?
Yeah.
Lot of instance.
Hmm.
So I need one clarification. So what is the difference for all? Click over there, and let me scroll up all the things. Instance type.
Instance type.
No, you can select that instance, right? That memory, C, compute, everything.
Mhm.
Yeah. Yeah. So here, there, it can look like lot of extents large like that, right?
Mhm.
Yeah. For this, what is the purpose and how we can differentiate and how we can understand these things? See, for example, C4 large,
Mhm.
C4 X large,
Mhm.
C4.2X large.
Mhm.
So in this case, how we can assumption and how we can get the info. What is the correlate? For
Mhm.
example, what is the correlation for all these things?
Mm. No worries. Okay, let me explain. Say, for example, generally it starts with medium. Okay, so when I say
Yeah.
medium, we'll say one CPU with a particular category, let's say 2 GB of memory. Okay, and then the large will have the next ratio 2:4. And then X large means it is one size larger than the existing one. So it will be 4 and 8 here. Okay, it is 2 times larger means it is 2 times the larger size of this one. So 2 times the large size. Okay, and then
Okay.
if you have 4x large, it is 4 times the larger size. So that is the ratio that they are saying.
2x large means into 2, like 8, and it should be memory
No,
also. It's a 2 like 16, correct?
2x the times of large. 2x, 4x the
Okay,
times
fine.
of large. Yeah,
Okay, 4x means 16, then 28. Okay, fine. Yeah,
that is true.
understood.
Yes, 16 and 32.
Okay, this is totally correlate with the kind of memory
Yeah.
or how the things in
See, not
IT.
really. This is I'm referring to the compute sizing. It is applicable for each and every category. So even if you go to memory optimized, also you might see 12x large, 8x large. Mainly the CPU to memory ratio is what they are denoting.
Yeah, fine. Yeah, understood. Thanks a lot,
Oh,
Stan.
fine. That's fine. Yeah. See, again, as a solution architect, you need to understand that certain instance type, for example, some older technology will support only 10 Gbps speed. Some latest generation might support 15 Gbps, 20 Gbps. The number of network adapter it supports might also be huge. So you have to check which particular version. Before raising a change request, you need to find out whether that particular instance type supports that much amount of network bandwidth or number of disk or the size of disk before you go and raise the change request. Because if the existing instance type does not support the quantity that you are targeting, then you might have to change the complete instance type. When you are changing the instance type, the downtime that is needed is very high. Okay, changing from one instance type to another needs more downtime. For example, if you're upgrading within the same instance type, there is not much downtime involved. Downtime is involved, but it is like very few seconds or minutes. Whereas when you are changing from one instance type, because it is a different hardware, right? So as I told you, they are using different processors, different systems. So it is different server hardware. So it is getting migrated from one system to another system. So it needs more downtime when you are getting migrated. See, as I told you, you always have to think about the number of network adapters, amount of disk supported, and all those things, because each versions will have different capacity requirements in terms of network ports, number of network adapters, number of disks, and so on. Okay, fine. Any other questions from anyone? We are on top of the hour now. Maybe I'll accept questions only. We'll continue with this EC2 in the next session. Next entire weekend, Saturday and Sunday together, we will just continue to discuss EC2 only. We have a lot of stuff to discuss, and we will learn different classifications and more details. See, there are a lot of different Intel processor versions that are being used by AWS in their uh, instance type. I'll give you more inputs around what are the differences and stuff that they provide. Okay, for now, based on the diverse workload requirements, you can go and choose different optimized systems based on the customer requirement. If there are no questions in English, Tamil கூட question கேட்கலாம். If in case you have some questions or if you have not understood something, feel free to ask in Tamil.
Stan?
Yeah, go ahead.
Stan, earlier we were discussing about the connectivity, right?
Yeah.
You mentioned that we have a jump server, like what we do in our on-premise. So the jump server will be on-premise jump server, and through that we will connect to the AWS instances, either Windows or Linux, correct?
It depends, Sindel. See, what you can do is, in order to manage the system, you can do it in two ways. One, you can have an on-premises, on-prem jump server or Bastion server or terminal server, which can be connected to VPN to AWS, and you can use the existing jump server, or you can create a AWS EC2 instance as a jump server, and you can also connect from there also to all the AWS resources. So in this way, once you are connected to the jump server, all AWS resources are accessible privately, right? Privately accessible, because you have private IP address. From here, it is already in EC2 is a service within AWS, so all the AWS resources can be accessed privately if in case you want to. But whereas if you're using on-premises jump server, you might have to use a VPN connection, point to site or site to site VPN to AWS, and then access it privately, or else it will need a public IP address to be accessible. Yeah, you can use anyways. I mean, either ways, but latency will be better in AWS EC2 instance. If you are using AWS EC2 as a jump server, that will be giving you better performance and better management.
Okay, because I got to know from the existing the application DevOps team, there are separate team in my company. What they say is they connect to our on-premise jump server. From there, they access the AWS instances, the Windows servers. When I checked with them like how you are accessing, they said I'm not sure. Like they just gave this IP address RDP and we connect from jump servers. I'm not sure how the connectivity goes, because we are on-prem team and the AWS is
definitely. In that such case, we will have a site-to-site VPN from on-premises to AWS. I'll show you how to configure site-to-site VPN. Practical session is there. After maybe 2 or 3 weeks, we'll see network practicals. At that time, I'll show you how to do a site-to-site VPN between two different sites.
Okay, yeah, because they say like they allow the jump server, either irrespective of the team, they have a separate on-prem jump servers. From there, they connect to multiple AWS Windows servers hosted in AWS. So I asked them
Yeah,
because since
see,
they're not aware of.
mostly what why on-premises jump server means they might have existing licenses, existing systems which are prepared
Mhm.
for it, and they might be having multi-cloud also, or different systems on hybrid cloud or multi-cloud setup where they want to use the leverage the existing jump servers, and also they want to do auditing of all the connections and access that is happening to any system. So it is like all the access, all the logs will be populated or available in your on-premise